Hi everyone. This video is inspired by one of my LinkedIn posts about understanding of spectrum that many of my friends found it interesting and reached out asking for a deeper explanation to how this spectrum thing work and how it is related with the resources that is being used in different generations of telecommunication, that is 2G, 3G, 4G or 5G. So I had decided to break this topic into three parts of learning journey. The part one will be having the understanding of spectrum. We will start with the basics, that what spectrum is and why it is foundation of wireless communication. Then in part two, we shall discuss about the understanding of air interface and the formation of frame structures, that we shall be able to relate it with the formation of resource blocks in the third part of the video. So we'll keep the videos very short, crisp and informative so that you will be getting some sort of idea, some information, technical information about how this radio frequency is actually working over the air interface. So let us quickly jump into the understanding of a spectrum. We have the basic content that has been already shared over LinkedIn about the understanding of spectrum and what spectrums that is being used in India and so on. What we are going to discuss here in this video is about the we are going to understand about what this spectrum distribution is, what is this radio frequency spectrums, why it is in TDD, FDD, how it actually looks like, how it is getting distributed over the air interface, or you can say how it is actually getting into the picture, from where this spectrum is coming into picture, or how why this spectrum is actually there. So let us quickly get into it. So what this spectrum is the electromagnetic frequencies, of course, that we know. Spectrum is the range of electromagnetic frequencies that is available for the transmission of your information in a form of signal, wireless signal. Yes. Now, it is a kind of path, you can say, or it is kind of carrier that is actually transmitting or receiving your information from a part from your mobile devices to the network, or from the network to your mobile devices. Whatever is being sent or received in the air is through the radio frequencies, and those radio frequencies are part of your spectrum. Now, how this spectrum is distributed, or how this spectrum came into picture. So we have numerous radio frequencies available on the air, air interface that is being used for different purposes. Like you can see in this chart, we have different bands like low frequencies, LF, MF, medium frequencies, high frequencies, very high frequency, ultra low frequency, or ultra high frequency. Then so we have different range of frequencies with different band names, and that is useful for different purposes. For now, what we are here is to discuss about the radio frequencies that we are using for telecommunication, that is wireless signaling or wireless information transmission or reception. So what we are having here is, you will see we have different bands here, and what is useful here for us is these bands, that is from radio. What spectrum range that we are using for mobile phones is UHF, SHF, EHF, Or nowadays we usually call it for 5G networks that below 6 gigahertz bandwidth, or we say it like centimeter wave spectrum or millimeter wave. So when we say below 6 gigahertz or centimeter waves or millimeter waves, it means these are the different bandwidths available or the spectrums available for your radio transmission. Now, what actually we are using our air interface, how this spectrum is getting distributed, and how it is being available to us through this second 2G, 3G, 4G or 5G network. So let us understand about this. For that, we'll have to have a basic understanding about FDD, TDD. That obviously we know. FDD is frequency division duplex and TDD is time division duplexing, and we are using frequency division duplex. A duplex kind of, you have two different frequency bands that we are using simultaneously to transmit and receive the signal from user to network. Means in uplink and downlink we will have two different uplink downlink frequency ranges. Now in TDD the same frequency range or the same frequency will be used. We split it into different time domain and we use it for simultaneous transmission and reception of your radio signals. So thing is is FDD is separated by UL and DL, and TDD is the same frequency, and cause it is separated by UL and DL uplink and downlink, so it is paired always, and it is unpaired, it will be a single frequency band. Yes, latency is lower in FDD, it is slight higher in TDD. Best for symmetric traffic. Yes, of course, we'll understand about what this symmetric traffic is or asymmetric traffic is. But for now, we are parking it and we will be discussing it when we will discuss about the resource blocks and its allocation. For now, we are understanding about the spectrum. For that, we were trying to discuss about what FDD-TDD is, and the basic thing is FDD is being used from a user to your network when it is transmitting uplink information or receiving any downlink information. It is being done over the air interface, and there is a bandwidth over the air interface, or a spectrum range or a range of frequencies that has been provided to the network. Let's say it is some of the service provider 01, and this service provider 01 has some sort of spectrum available, and that spectrum is having some bandwidth, and that bandwidth is being used by the service provider for uplink and downlink transmission. Let's understand how this bandwidth is being provided to the service provider, how it is being done. So what frequency ranges or how much bandwidth is there is a chart that is actually showing you what we use in FDD. We have different frequency bands. You can see for FDD we have different bands, where 1920 to 1980 is one of the frequency range for uplink, UL you say it, and for DL you have a separate downlink frequency range. Of course, we discussed it that FDD will be having a pair of frequency ranges for uplink and downlink transmission. And when you talk about TDD, we have single range of frequency that we use for DL as well as UL. Yes, and the different reasons where these frequency ranges are being used is kind of summarized here. But for now, we are trying to understand what this spectrum is and from where these ranges are actually coming into picture. How do you come to know that these ranges are available, and how much out of these ranges actually your service provider have? Is it the complete frequency band, let's say 1922 1980, it means it has 60 megahertz of frequency range. And is it that your service provider will have all the 60 megahertz of bandwidth available for uplink, and this is again 60 megahertz of bandwidth? Is it being used by a single provider for downlink? No. So how it is being done? Let us see. For this, let's move to one of the chart that make it easier to understand how it is getting distributed. For now, what we had in this chart is we had the FDD frequency ranges, we had TDD frequency ranges, and the millimeter wave. Millimeter wave is the higher band that is nowadays available by some of the operators globally for the higher utilization of resources, or they will have higher bandwidths, higher resources available over the air interface. But thing is, these higher bands, higher the bands or higher the frequency ranges, if you say 26 gigahertz to 29.5 gigahertz, it means it has very high frequency range, which in turn tells you that the transmission of these radio waves will be very limited to around, you can say, around 40 meter to 100 meters maybe, or lesser. If you want to get a good coverage for these frequency band through a transmission of antennas, it will be around 40 to 100 meters. That is again because we'll be using advanced antennas for these frequencies, and that too will be small cells or different kind of indoor outdoor cells for limited transmission ranges. But these ranges, these 100 meters or 40 meters of range of these frequency bands will be higher and higher resource availability, which makes it very compatible to be used around your world, telecommunication world, where nowadays data is a basic requirement, and we need better and better customer services from the service providers. That means the resource availability around you should be better, and to make this resource availability better, you will have to make the resources available. And to make the resources available in the most of the time in the urban areas, we use the higher frequency ranges nowadays, that is through the wave. Yes, of course the ranges, the transmission limitation is there. That is why all the service providers nowadays are creating a heterogeneous network using the small cells, and you will be getting very excellent radio resources available around you. Now, jumping back to the chart to understand from where these ranges are coming and what actually you are going to get, or your service provider is going to get out of these ranges, how it is getting distributed and all those steps. So I'm jumping back to one of the chart that is available for the 5G spectrums nowadays that was used. Let me jump to that sheet. So this is again, this chart is from the Wikipedia, and you can see different frequency ranges. For now it is for frequency range 1 and frequency range 2. That too is for 5G, you can say, for now. So different frequency ranges are there that we have named it N1, N2, N27, N12, and 13. Different frequency ranges are there. Now when you see if it is FDD, that is duplex mode is FDD, or TDD, in the chart we have TDD as well. When you say FDD 2100 megahertz band, it will be giving this range of frequency ranges available. Let's say in uplink in UL 1920 to 1980, that we were discussing in our last chart, yes. And in downlink it is available 2110 to 2170. It means we have total 60 megahertz of spectrum range available in uplink, and here also when you subtract this to this you will get how much? 60 megahertz of frequency ranges. And now when you have 60 megahertz of frequency ranges in uplink and downlink, what bandwidth that is required by the operators to make the resources available for your different services. Let's say for 5G, if I talk about 5G, you need minimum 5 megahertz of bandwidth to make proper resources available for the users, we'll say practically. And so 5 megahertz is the minimum requirement. So 5, 10, 15, 20, you can say 5, 10, 15, 20, 25, 30, 40, 45, 50 megahertz of bandwidth that you can have in your network to provide the services. But again, because these ranges are limited available over the air interface, let's say uh, government have available this much of frequency ranges 1920 to 1980 to be transmitted within India, let's say. And in India, different cities will have different bands. Yes. Now in India, if I say I have FDD frequency ranges 2100 band for XYZ operator, so XYZ operator can opt 5 megahertz of bandwidth out of this 60, let's say. So operator 1 will have 5 megahertz, operator 2 maybe their requirement is more, they will opt for 10 megahertz, they will bid for 10 megahertz, or operator 3 that they will be bidding for more bandwidth, that is 20 megahertz maybe. So there is requirements of the operators or their constants of budget decides how much bandwidth they want to have out of this frequency range during the bidding, and this is how they will be purchasing these frequency bands. They will be kind of signing off for 5 megahertz of bandwidth, let's say, and government says you will be getting 1920 point something to 1920 point something to 1920 4.9. This much of frequency range is for you 5 megahertz, and after this 10 megahertz again a different frequency band, so that all the different operators will be having can have the same band, 2100 band with operator 1, 2100 band with operator 2, maybe 2100 band with operator 3, with different frequency ranges or bandwidths that will be allocated as per the bidding that has been done by the operators. And it may be operator 3 will purchase 20 megahertz, and again operator 3 wants 5 more megahertz of bandwidth. That is the possibility because we have carrier aggregation too. Yes, so multiple bandwidths is a possibility to be having to a single operator, or a single bandwidth, or multiple bandwidths. So that is one of the possibility. And when we say there is 3 operators who has purchased this much of bandwidth, it means different frequency ranges that has been purchased. And when we add these, let's say we will have 5 plus 10, it means 40 megahertz of bandwidth is already, it has been purchased by bidded by some of the operators, and now the available frequency range for this 2100 band is available is 20 megahertz is only spare or available. So this is how these frequency ranges are getting distributed to us number of operators within a number of operators, and same band will be available for different operators, but they will be having different set of frequency ranges. And how it is getting distributed we discussed, and what are the requirements. We have different requirements for channel bandwidth, like minimum it should be 5 megahertz and maximum 50 megahertz of bandwidth one operator can have depending on the distribution it wants to make. Now if we'll say this chart in Wikipedia, frequency range 1, it's saying FDD, and when we say FDD, when we go down, scroll down, we see different TDD ranges are also there, and when we see TDD ranges, we'll see when we see TDD, there is only one frequency range. Why it is so? We discussed that FDD is having duplexing technique through UL and dual different frequency ranges, and when we say TDD, we need only one frequency range, frequency range for uplink and downlink simultaneously. And again the requirements are different. In TDD 2100 band, if it is available, how much it is? 2010 to 2025. It means total 15 megahertz of bandwidth is available. Out of this 15 megahertz, different operators can bid for different frequency ranges. Maybe one operator says that operator 1 will say I will have 10 megahertz of bandwidth for this TDD frequency range, and other operator 2 will say I want 5 megahertz, but we have limitation here that we have total 15 megahertz. So if two operator has already opt for 10 megahertz and 15 megahertz, 5 megahertz, it means total 15 megahertz is already done, and the third operator will not get any frequency range out of this 2100 band. Similarly for other ranges, N41 if you say, or N47, different frequency ranges are there nowadays that is available for radio resource allocation or spectrum availability for the operators. Now when you understand that this frequency ranges, or this how this FDD or TDD frequency ranges are getting allocated over the air through the spectrum distribution, you will get to understand that after the distribution, let's say operator 1 has 20 megahertz of bandwidth, single bandwidth available for FDD 2100 band, let's say. So where is it? Let's say here it is. If operator says I have a FDD duplex mode of 2100 band, out of this 1920 to 1980 or 2110 to 2170, I have purchased a bandwidth of 20 megahertz. It means 20 in UL and 20 in DL. Yes, of course. And few things like duplex spacing. If you talk about what is this 190 spacing, means the difference between these ranges. So 1920 to 2010, if you see, the difference is 190. So this spacing is made available between two uplink and downlink frequency ranges for different technical purposes. Maybe you can relate it with the interference, but for now we have different set of frequency ranges for uplink and downlink that you should understand through the different, how this different band works, or how this spectrum thing works. We have understood. Now in second video we will directly jump into understanding of how this FDD or TDD air interface frame structuring happen, how this frame structure is working over the air interface, or how we are creating this frame structure, how this frame structure will be used to map as a resource block or as resources, and why it is called resource blocks or why it is called resource units how these resource blocks will be used for the allocation of the transmission and reception of your data in the air interface we'll discuss in next two videos. Thank you so much guys. Stay connected.